The DAB Plus Advanced Measurements option makes the ATLaS NG compatible with digital audio broadcast standards DAB and DAB Plus. With this option, while in the spectrum analyzer mode, we can tune any DAB Plus signal, and the meter will automatically detect the modulation parameters and demodulate the signal. When we head to the measurements tool, which I will maximize now, we can see the basic measurements, quality measurements for DAB Plus, like power level, carrier to noise, MER, and the channel BR. But as well, we show some very specific measurements for DAB, which are the channel BR for the MSC, the FIC, and as well we show the FIB ratio. The MSC channel BR is the channel BR calculated only on the main service channel. The main service channel is the part of the ATI. The ATI is the equivalent to the transport stream in DAB. So when we calculate the channel BR on the MSC, what we are doing is calculating the channel BR only in the part of the ATI that stores the digital audio service data. The services, the digital radio services themselves. While when we calculate the channel BR on the FIC, FIC stands for Fast Information Channel, what we do is calculate the channel BR on the part of the ATI that stores the metadata, the tables of the ATI that allow the receiver to extract and retrieve all these digital audio services. And the FIB ratio, FIB stands for Fast Information Block, is a measurement that calculates the percentage of errors in the checksum calculated over the Fast Information Channel. So here what we want is to have a 0%. That will mean 0% of errors. To sum it up, the most important measurement here is the FIB ratio. We should look for a 0%. If we don't have any errors here, so we have 0% of errors. This means that we don't have any mistakes or erroneous bits in the Fast Information Channel part of the ETI. If we don't have any errors there, it means that the receiver will be able to find the information from the ETI tables that allows the receiver to extract and retrieve the digital audio services. Then we will check the FIC channel BR, and finally we will check the main service channel channel BR, which gives us an idea of how many erroneous bits are in the data associated with the digital audio services themselves. If we go to the video tool, we can see the full list of radio services carried by that DAB channel. The signal parameters tool will display all the modulation parameters for that DAB carrier that we are demodulating. And the video audio parameters tool will provide all the comprehensive information about the ensemble, ETI, and the service selected. There are other advanced measurement tools for analysis of DAB signals. For example, DAB signals are modulated in DQPSK modulation. If we go to the constellation, we can see indeed that this is a DQPSK modulated signal, and we can see the quality of the symbols received. DAB Plus is using OFDM as well as a transmission scheme, meaning that the available channel bandwidth of 1.6 MHz is divided into a large number of narrow and orthogonal subcarriers. You can now check the MER of each one of these carriers in the MER by carrier tool. In this plot, the total number of carriers in the tuned DAB channel is displayed in the horizontal axis, and in the vertical axis what we can see is, instead of power level, we see MER value. So now we can press on any of the carriers and we will see the number of the carrier that we just selected, and its MER value, plus the average MER value of the whole ensemble of OFDM carriers. It's important as well to note that DAB and DAB Plus signals can be transmitted under SFN networks. Therefore, it would be very handy to have a meter that features an echo analyzer to check if the main signal that we are receiving from the main transmitter is being interfered by echoes that are coming from distant transmitters. The echo analyzer is used in the same way that you would use it for analyzing DVB-T or DVB-T2 signals. We will find the echoes analyzer tool as well by unfolding the tools menu, selecting echoes. You can find here the main signal and all the echoes in the echoes analyzer plot. From the tool preferences menu, you can zoom in and zoom out. For each one of these signals, for the main signal and the echoes, you can see their power level with respect to the main signal, their delay in microseconds with respect to the main signal, and as well the distance that each one of these echoes have traveled with respect to the distance that the main signal has traveled. Everything that falls inside the guard interval is the area displayed between the red blocks, and in the red blocks we represent everything that happens outside the guard interval. Another tool for DAB analysis is the ETI recording tool. To access to that tool, we go to the tools menu, choose recording, and here, where we are tuned and demodulating the DAB channel, we can press the recording button and start recording the ETI. The ETI is the baseband signal of a DAB channel. It would be the equivalent signal to the transport stream in DVB-T or DVB-T2 standards. The unit will start recording the ETI in the internal memory of the unit. Once we are done, we press again the same button, the stop recording button. The file will be stored in the internal memory of the unit, but we can export it to an external pen drive from the workspace. Now, I want to show you another tool, is the Shaldos attenuation measurement tool. We already explained this tool previously, but I just wanted to tell you that it is possible to take this measurement as well over DAB channels. And finally, the last tool I want to talk about is the TII information, the TII analysis tool. In DAB, before you transmit any set of symbols using all these thousands of OFDM carriers, you transmit before that, alternatively, either null symbols or phase reference symbols. What you see in this graph is, in yellow, null symbols. As you can see, some of the carriers, some of the OFDM carriers are active. These OFDM carriers that are active are transmitting two identifiers, something called main and sub. The main identifier describes the country and region where the signal is being transmitted to, where it's being broadcasted to, while the sub identifier describes the transmitter from which we are receiving this broadcast. So the unit will be able to extract the information from these two identifiers, and as well in green is showing you this other information that is being broadcasted alternatively with the null symbols before the transmission of the digital radio services, which is the PRS symbols. We see them in green. PRS means phase reference symbols, and this is the information that the receiver requires in order to synchronize to the DAB signal before it starts demodulating the DAB signal and extracting the digital radio services. So you can see both sets of information, null symbols carrying these main and sub identifiers, and the PRS symbols, both of them in different colors, so it's clear in this plot. We can provide you as well with an XML file in which you can set up, you can edit the description for every combination of main and sub identifiers. So once the unit has demodulated the DAB signal, it will extract this information, the main and sub identifiers, and will present as label the description that you have edited in this XML file.